Hey everyone, welcome to 3.2, Graphing Standard Form Quadratics. First things first, standard form looks like this. ax squared plus bx plus c with a y equals in front. So you'll notice there's no parentheses here, which means that we can't use the transformations we did in the last section. Standard form is just not set up for transformations. So instead, we have to use a formula to find the vertex so that we know where the middle of the quadratic is. And that vertex formula is x equals, and then do this with me really quick, negative b over 2a. Then you plug x into the equation to find y. Because remember that your vertex should be a point x comma y like this. Then you're going to have the axis of symmetry. I started drawing this with you guys a little bit in the last section. It's a vertical line that goes through the middle of the parabola. Okay, a parabola is the shape of a quadratic graph, by the way. And then one note I'm going to make about this is that it is going to be a dashed line. Because it's not really a part of the parabola, it's more just a reference line. This is the line across which the graph is symmetrical. So whatever happens on one side flips to the other side. And on the axis of symmetry, x equals the x value of the vertex. Because it's a vertical line, so it's going to be x equals, and then your answer from up here gets used here as well. So the same information goes on here twice. Some people are going to love this section because you're following a formula. If you want to know where in the world this comes from, it comes from the quadratic formula. It's the first part, or it's the outside pieces that aren't under the square root. Obviously, because we don't have a square root here. So we'll kind of get to that and talk about where this came from again, but that's why that is the vertex. Here's how it works. This is A, B, and C. You do not need to label them every time because they go in order, so it shouldn't be that hard to keep track of them. But you're going to take the opposite of B on top. So it's 8 right now, it's going to become negative 8. Divided by 2 times A. A is negative 2, so this will be 2 times negative 2. Which really is negative 8 divided by negative 4. Well, negative 8 divided by negative 4 is 2. So that's the first part of your vertex. And your axis of symmetry is going to be the vertical line x equals negative 2. So I'm going to go to negative 2 and draw a line going up and down. Sorry, go to positive 2. Up and down. And then we're going to take that number 2 and plug it into the equation. Here's the thing. You're going to square 2 and then multiply it by the negative 2. Okay, so 2 squared is 4. 4 times negative 2 would be negative 8. Plus 8 times 2 is 16. Plus 10. Which ends up being 8 plus 10. So 18. Or take out your handy dandy calculator. Sorry. And do negative 2, parentheses, 2 squared. The only thing that goes inside the parentheses is the number you're plugging in. So the negative 2 can't go in there and the squared can't go in there. Plus 8 times 2 plus 10. 18. And since 18 doesn't fit on this graph, here's what we're going to do. We're going to triple all of these values. And I promise you this does not happen again. 18, 15, 12, 9, 6, 3. That way we can put it right here. And I apologize for that. All of the homework problems are okay. None of the other examples go off. And then the very last piece over here, and all these parts to the side are the parts I want you to do in order to graph it, is we want to figure out what the y-intercept is. If I'm on the y-axis, x is 0. So what we're going to do is plug in 0 for x. So I can copy down what I just did with the 2, but instead of plugging in 2, I want to plug in 0. So I can just go change that number to a 0. To get this line back, you just hit second enter, by the way. So second enter, and you can get any line back that you've already done. And then you can just type over it and make it a 0. And it's 10. Guess what, guys? 0 squared is 0. 8 times 0 is 0. So the only number you're ever going to have left for the y-intercept is the last one. And that's about right here between 9 and 12. And then this is the part that we're not going to write down. This is going to be one of those things you just have to understand, get used to, and remember. This is 2 squares away from the line of symmetry. So if I stay at the same height and I go 2 squares this way, I have myself another point. And I can draw my U, just like that. Right? And then the last thing at the very bottom says maximum or minimum. This one has a maximum, because it's at the top, of 18. Perfect. Next one. X equals negative b. So negative 6 over 2 times, there's no a value, so you can put a 1 if you want to, which is really negative 6 divided by 2, which is negative 3. And then we need to take negative 3 and plug it back in. Negative 3 squared is 9. 6 times negative 3 is negative 18 plus 5. Or you can plug it into your calculator the same way I did the last one. Redo negative 3 squared. Make sure you're using those parentheses. Plus 6 times negative 3 plus 5. Which is the same thing as 9 minus 18 plus 5. So you pick the way that you would rather do that. Some of us are more comfortable with mental math because we get to do it ourselves. Then the axis of symmetry that I forgot to write down is at negative 3. So my vertex is left 3, down 4, and there's a vertical line going through it like this. And then my y-intercept, you plug in x equals 0, and you're going to get 0 squared is 0, plus 6 times 0 is 0, plus 5. So it's just 5, which is right here. This time we are 1, 2, 3 squares away. So I have to go 1, 2, 3 squares on the other side. Like this. So basically, you're using the vertex to get you started because you have to know the middle of the parabola. And then the y-intercept is just a really easy point to pick because plugging in x equals 0 is really easy. I could technically plug in x equals 1 or x equals 2, but that's not always going to be helpful. It depends on where the vertex is. Every single time you're going to want to be able to find the y-intercept. This one happens to have a minimum because it's got a bottom right here at negative 4. So this one bottoms out instead of having a peak. Let's do 2 more. This third one's a little funky because it's 2x squared plus 8x. So you have an a value, a b value, but no c value. So it could be a 0 at the end. We call that a 0 placeholder. And you only use it if that piece is missing entirely. Okay, so my vertex is going to be negative b, which is 8. By the way, if b was already negative, you would make it positive. Over 2 times a, which is 2. So I have negative 8 divided by 4, which is negative 2. And then I'm going to go plug that back in. Negative 2 squared is 4. 4 times 2 is 8. 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 4 ti Negative 2 times 8 is negative 16. And 8 plus negative 16 is negative 8. Or take out your handy dandy calculator. 2 parentheses negative 2 squared plus 8 parentheses negative 2. So I'm just replacing these two x's with parentheses negative 2. Same answer. Okay, then my axis of symmetry is negative 2. It's the same thing as the x value. And my y-intercept is 0 plus 0 plus 0. It's always going to be the same thing as the last number, which is just 0 in this case. So I'm going to go to my vertex, negative 2, negative 8, and draw a dashed line going up and down for the middle of that. That's my axis of symmetry, and then my y-intercept is 0. That is 2 away from the middle, so I'm going to go 2 to the other side. This one asks you for the domain and range. Domain goes left and right, so that's left forever, right forever. The domain of any quadratic should be negative infinity to infinity, because these are your x values, and there's no x values that you aren't allowed to plug in. All x values are fine. The range is going to stop because when you square something, it only gives you positive numbers. So there's only going to be a certain number of values that it will give you as your answer. This one happens to stop at negative 8, and then it goes all the way up to infinity. And since that's a whole number, we're going to use a bracket. And our very last one, I'm going to go through this one a little bit quicker, just so you guys can see an extra example. Negative b is 6 over 2 times negative 3 is also negative 6. That's 1. Negative 6 divided by negative 6 is 1. When I plug in 1, this is going to become negative 3 plus 6 plus 2, because multiplying by 1 doesn't change these numbers. Negative 3 plus 6 is 3, plus 2 is 5. So I'm just plugging this number in and figuring out what the answer is. So over 1 up 5, and your axis of symmetry is going to be over there at 1, going through that point. Then your y-intercept, 0 plus 0 plus 2. And it's only 1 away, so we flip it across to the other side, and we have our parabola. The domain is still going left and right forever, as it always will for quadratics, but the range goes down forever and stops going up at 5. So notice how this one went up forever, so the infinity was on the right side. This one's going down forever, so the infinity is on the left side.